In this lesson, we're just going to take a few minutes to review solving quadratic equations and then look at a certain thing we can do to find out the amount of solutions we'll have and the type of solutions. So just as a review, this kind of reviews the last several lessons. To solve a quadratic equation in the form ax squared plus bx plus c, we have four options right now for solving these. Our best and most efficient way to solve is, if possible, is usually factoring. So if you can factor, you should do that because that's quick. If you recognize that b is equal to 0, this should be a lowercase b. If b is equal to 0, so you just have a squared term and a constant term, then you should be able to solve by taking square roots. If neither of those work, those you can usually tell quickly if they're going to work. Go ahead and use the quadratic formula. We learned completing the square, but really completing the square is inefficient, so you only do that if you're told to do so. So what we're going to focus on today is this idea called the discriminant. The discriminant of a quadratic equation is b squared minus 4ac, and you should recognize this as what is under the square root in the quadratic formula. And we can use this if we want to know the number of roots or solutions and the types of solutions, so rational, irrational, or complex, by knowing the value of the discriminant. So what we're going to do is we're just going to check out several numbers really quickly. This is easy to find, and we'll do this a little bit later. You just make sure you know what A, B, and C are, plug it in, and find the value. So we're going to look at if we came across a discriminant. I want to know how many solutions you would have and what type of solution. So if you had 25 as a discriminant, so I'm going to start off by just kind of thinking of the quadratic formula, and this is why the discriminant tells us these things. So b squared minus 4ac all over 2a, and I should put x, or our variable, is equal to this. I forgot the b, negative b. The reason we look at the discriminant is because it's under a square root. So if we get a 25 under the square root, 25 is a perfect square, so you'd have some number plus or minus 5 all over some other number. So we would have two solutions because we would be adding 5 to negative b and then dividing by 2a, and we would be subtracting 5, and all those would be rational numbers. So we would have two solutions, and we would have two rational solutions. What if we got negative 43 as our discriminant? Well, thinking if we get negative 43 here, we know that if we have a negative underneath a square root, we know it's an imaginary number, so we would have complex solutions. And again, we would have two, because we would take negative b plus this complex number over 2a, and then negative b minus. So we still have two, but this time we have two complex, or two imaginary solutions. 49 is 7 squared, so it kind of fits the same idea as 25. We had a negative b plus or minus 7, because the square root of 49 is 7, all over that. So we would have two solutions, and we would have two, it would be rational. Well, this one's a little different. This is a positive 61. 61 is not a perfect square, so we wouldn't get, like here, we would take the square root of 25 and get 5, or the square root of 49 and get 7. Well, 61 is an irrational number, so we would have negative b plus the irrational number over the denominator and negative b minus. So we still have two solutions, and they would both be irrational because 61 is not a perfect square. And we could actually think similarly with 87. 87's not a perfect square, so for the same reasons, you would have two solutions, and it would be irrational. What if we have 0? If you have 0 in here, you would have the square root of 0, which is 0. Negative b plus 0 over a number is the same as negative b minus 0. And so you actually get the same solution for the plus part and the minus part. So in this case, we would only have one solution, and it would be rational because it would be just negative b over the 2a. 28. 28 is not a perfect square, so it kind of fits the 61 and 87 idea. So we would still have 2 rational. Negative 12, it's negative. Negative would go under a square root, which gives us complex solutions. So that one's, whenever you have a negative, it makes it kind of easy because you should have 2 complex solutions. 100. 100's a perfect square. Fits the same idea as 25 and 49. So 2 rational. And then negative 25. And once again, it's negative, and so it's 2 complex. Don't get confused by the fact that 25 is a perfect square. This negative kind of trumps all the other things. If it's negative, it's definitely 2 complex because you have a square root. I mean, a negative under the square root. So what we're going to do here is we're going to kind of summarize this. So we have a chart here, a conclusion, and we're going to look, and we're actually going to start at the lowest. So we're going to look at what if the discriminant is less than 0. So if the discriminant's less than 0, it's negative. Well, we know if it's negative under a square root, we have 2 complex solutions. Next, we'll look at what if it is equal to 0. So we're starting in the negatives, working our way up. If it's equal to 0, we saw that we would have one solution, and it would be a rational solution. The next one, we're going to talk about, both of these we're going to talk about positive or greater than 0, and we're going to talk about greater than 0 and if it's a perfect square. That was our 25, 49, and 100. We had 2 rational solutions because you could take the square root of those perfect squares and get a rational number. And then our last one is it's greater than 0 or positive but not a perfect square, and we got 2 irrational solutions. So without solving, determine the number and type of solutions for the following quadratic equations. Well, we have to make sure they're in quadratic equation form, which means we want our quadratic term, our linear term, and our constant term in order, and then equal to 0. We can look at this and think, okay, A is 3, B is negative 4, and C is 7. And so we can just figure out what b squared minus 4ac is. So we got negative 4. So again, we're using the discriminant, b squared minus 4 times a times c. This is 16 minus 84. 16 minus 84 is going to be a negative, so actually you know our type of solutions. The fact that it's going to be a negative, so we know that it's 2 complex solutions. Next one, it is in the correct form, quadratic linear constant. In this case, we could actually simplify this a little bit because it's equal to 0. We could divide everything by 4. What that's going to help us with is, so we're not trying to solve, we're just trying to figure out the types of solutions. So divide everything by 4, we'll have smaller numbers to work with. And then we can think A is 1, B is equal to negative 6, and C is equal to 9. So we have B squared, so negative 6 squared minus 4 times A times C. And this is 36 minus 36, which is 0. And so we have 1 rational solution. We can refer up to here. If you get 0, we have 1 rational solution. Last one, this is not in the form that we wanted, so we're going to subtract 11 from both sides. So we get 2x squared plus 9x minus 11 equals 0. So be careful to put it in the right form. We're just going to figure this out. It's b squared, so 9 squared minus 4 times a, which is 2, times c, which is negative 11. And we have 81 plus 88, 4 times 2 is 8, times negative 11 is negative 88, but we have minus a negative 88. 81 plus 88 is 169. 169, if you take the square root of that, you get 13. So this is a perfect square. So it fits its positive and a perfect square. So we're going to have two rational solutions. And that is how you can find the number and type of solutions for a quadratic equation.